Hello, my dear children. So, you are aware that we are doing chapter based on light, and we have also learned about the laws of refraction. In one of the laws of refraction, we learned about Snell's law, which tells about refractive index, denoted by the letter mu. So today we are going to do some numericals on this refractive index. So before we proceed with the numericals, let us see some working formulas that we may use when we solve this numericals. So you'll find these numericals on your book as well in the exercise number A. Okay, so the first formula that we are going to use in this numerical, okay, in this particular exercise are: number one, mu as refractive index is given by sine of angle of incidence, which is in the rarer medium, to the sine of angle of refraction, which is in the denser medium. This relation is also called as Snell's law. Number two working formula is the refractive index is again given by one more relation, that is, it is by the ratio of the speed of light in vacuum by the ratio of light in the medium. Third relation of refractive index, that is mu of the second medium with respect to 1, is given by the speed of light, that is speed of light in medium 1 by speed of light in medium 2. The fourth relation that we have is again the refractive index of second medium with the first medium, but here in place of speed we'll use the wavelength. So wavelength of light in medium 1 divided by wavelength of light in medium 2. So please note these four formulas that I have written here. These are the formulas that you have to use whenever you are doing or solving numericals based on refractive index. Is it okay? Alright, so let's proceed to the first numerical that we have today. The first numerical that we are going to do today is this one. Question number 1. The speed of light in air is 3 into 10 to the power 8 meter per second. Calculate the speed of light in glass. The refractive index of glass is 1.5. So these are the two information given here. Number one is the speed of light in air, and the other one is the refractive index of glass, and we are asked to find the speed of glass. This is our motive, isn't it? So as you know, you need to follow the 4 rules. The first rule is to jot down the information given in the question under the heading given. So given speed of light in air, that is C, equals to 3 into 10 to the power 8 meter per second. Alright, then the other information given is refractive index, okay, of glass, that is mu, equals to 1.5. Alright, so if you see the units, rule number 2, compare the units. Units are fine here, since refractive index has no unit because it is the ratio of the same physical quantity, okay, and the speed of light is given in meter per second. That's fine. So now we'll proceed with the third rule, that is to use the best relation. So among the relations that I gave you, the relation that we are going to use here is mu is equals to, we know mu equals to speed of light in vacuum or air divided by speed of light in glass. Okay, that is represented by V. or if I make V as the subject here, I'll get C, that is speed of light in air, divided by refractive index, which I get as 3 into 10 to the power 8 after I replace the values of the speed of light in air, that is C, divided by refractive index, that is 1.5. so this will give me now 3 into 10 into 10 to the power 8 divided by 15. So here I got this 10 because I've removed the decimal from the denominator. Okay, meter per second. So now I'll get 3 ones are 3, 3 fives are 15, 5 ones are 5, 5 twos are 10. So I am now left with 2 into 10 to the power 8 meter per second. So this is the speed of light in glass. Okay, so now don't forget rule number 4, that is to write the statement. So please write the statement here, that is the speed of light in glass is 2 into 10 to the power 8 meter per second. Okay, so I hope now you understood the first question. It's very simple question. All right, so now let's move to the next question, that is question number 2. Now when you see question number 2 here, let me read the question. It says the speed of light in diamond. So here the optical medium is diamond and the speed is given as how much? 1,25,000 kilometer per second. What is its refractive index? So here we have to find refractive index. This is our question mark, and the speed of light in air is given, and that is how much? 3 into 10 to the power 8 meter per second. So let's proceed by writing under the heading given the information which is given in the question. Okay, the first information given here is the speed of light, where? In diamond. So speed of light in diamond equals to 1251230 kilometer per second. All right, yes. And what is the other one given? Other thing given is speed of light in air. It's given, and that is how much? 3 into 10 to the power 8 meter per second. All right, and we are asked to find the refractive index. So refractive index of diamond is question mark. So rule number 1 over. Rule number 2, compare the units. So here you see the unit is kilometer per second and here is meter per second. So they are not matching. So I must convert kilometer into meter. So you know 1 kilometer equals to 1000 meter. So here I'll get 125,000 into 1000 will give me meter per second. All right, so this I can write as 125 into 10 to the power, how many zeros are here? 3 here and 3 there. That makes 6, isn't it? So I'll get 10 to the power 6 and the unit will be meter per second. Now here I have the unit meter per second. Here also now I have the unit as meter per second. Now both the units are in same system, isn't it? So rule number 2 is over. So rule number 3, I have to use the best relation. So we know refractive index of diamond equals to C by V. You know the formula, isn't it? C means the speed of light in air, and what is V? V is the speed of light in diamond here. Okay, so I'll get 3 into 10 to the power 8 meter per second divided by 125 into 10 to the power 6 meter per second. So 10 to the power 6 cancels this 8 and leaves only 2 here. Okay, so how much do I get here? I get here 300 divided by 125, because here 10, okay, here I am getting 10 and square. 10 square is 100. 100 into 3 will give me 300. Right, so let me cancel with 5. So 5 6 is 30, 5 zeros are 0, 5 2s are 10, 5 5s are 25, 5 1s are 5, 5 2s are 10, 5 5s are 25. So I am getting 12 by 5, and 12 by 5 means 5 2s are 10 and remainder is 2. So when I point here, that becomes 20, and 5 4s are 20. So I get the refractive index of diamond as 2.4, and here it will have no unit because this meter per second and meter per second also gets cancelled here. All right, so rule number 3 is over, and write follow the rule number 4 here, that is to write the statement. So I hope you understood this question also. It is very, very simple, just the direct apply of the formulas. Okay. All right, so now let's move to the next question. The third question that you have in your book is question number 3. So the refractive index of water with respect to air is 4 by 3. What is the refractive index of air with respect to water? So here, refractive index of water with respect to air is given, and you're asked to find the refractive index of air with respect to water. So let's jot down the thing. So given refractive index of water with respect to, this is a short form in which you can write with respect to, with respect to air, which you can write as refractive index of water with respect to air. In this way you can write is how much? 4 divided by 3, 4 by 3. Okay, so now you are asked to find the refractive index of air with respect to water. So we know the relation. I have taught you this relation, that is refractive index of air with respect to water is the reciprocal of refractive index of water with respect to air. It's very simple. So you get one more working formula here, so you can add this also, or refractive index of air with respect to water equals to 1 divided by 4 by 3. So now this becomes, after I take this 3 to the numerator, it becomes 3 by 4, which gives me as 3 4 zeros are 0, then I'll get point here, so that becomes 30, 4 sevens are 28, remainder is 2, and since I have decimal here, so that becomes 20, and 4 5s is 20, so I get 0.75 is the refractive index of air with respect to water. So this question is a bit different one, but very, very simple. You just have to remember this relation to find the refractive index. All right. Okay, so now let's move to the last question for today, that is question number 4. Question number 4, what does it say? It says a ray of light of wavelength. So here now the question is based on wavelength. It is 5400 angstrom. So the symbol of angstrom is capital letter A. On top of A there will be a small circle, that is what we call angstrom. This is the unit of wavelength, that is denoted by lambda. Suffers refraction from air to glass, taking the refractive index of glass with respect to air is 3 by 2. Find the wavelength of light in glass. All right, so let's jot down the given thing. So given refractive index of glass with respect to air is how much? 3 by 2. All right, and the wavelength of light, wavelength of light in air, wavelength of light in air is how much? 5400 angstrom. So now we are asked to find the wavelength of light in glass. That is our question, isn't it? So let's use the relation. We know refractive index of glass with respect to air is given by the relation, that is wave length of light in air divided by wave length of light in glass. Or let me put the values. I'll get 3 by 2 equals to the wavelength of light in air is 5400 divided by, okay, wavelength of light in glass. So now I have to cross multiply. So when I cross multiply here, what do I get? I get wave length of light in glass equals to 2 by 3 into 5400. Alright, so now this gets cancelled by 3. 3 ones are 3, 3 8s are 24, and 0 here. So 2 zeros is 0, 2 zeros is 0, 2 8s are 16, 2 ones are 2, plus 1 is 3. So 3600 angstrom. So I got the solution here. So now don't forget the last rule, that is to write the statement. So I hope you understood here. It's very simple numericals. So I've solved all the numericals for you all. Alright, so please do this properly, note down this properly in your copies. Okay, if you are getting confused somewhere in between, you just ask me. Alright, okay, so now today's assignment here I'm going to give you. Okay, so please note down the assignment for today. Okay, so today the assignment is based on yesterday's video, that is on prism. Okay, so I have the cross-sectional surface of prism, and the segment that I've taken is A, B, C. Okay, here I have one ray which is entering here. Here I have the normal. Okay, it gets refracted and this ray comes out here, and here I have my normal. If I draw the continue the detection of incidence that way, and I produce the emergent ray backward, I get some angle here. Alright, so let this angle be x. Okay, so let me name this P, Q, this point is Q, this point is R, and this is S. Is that understood? Okay, so name the following. So you must name the following. You have to copy this diagram. Okay, copy this question, and here you write the answers. Okay, PQ. What is PQ? You have to name it. Number 2, what is QR? Number 3, what is RS? Number 4, what do you call the angle BAC? And number 5, what do you call to the angle X? Okay, so you have to name this 5. So this is your assignment for today. Alright, so that's all for today. Thank you so much.